Hello everyone. In this video we're going to continue our series on Civil 3D Superelevation. This will be part 2 in the series where we take a look at the basics of the design criteria file. If you'd like to go back and review part 1, it's simply an overview of Superelevation in Civil 3D. So let's get started. As a reminder, we have an alignment with a single arc. This arc has a 1200 foot radius. I'm going to select the alignment, go to Alignment Properties. And as a reminder from part 1, we set a design speed of 50 miles per hour. And we picked a criteria-based design. So what is our criteria file? Well, we deliver several for you to choose from. I have one that's custom. Now these files can be edited with a simple text editor like Notepad, or maybe an XML editor like XML Spy. Okay, I'm not going to do that here. I'm just going to select the file. And I'm also going to say, what is my minimum radius lookup if I use that piece? So I'm going to say 6%, and that's 6% maximum superelevation rate. See, the alignment is ready to have super calced for it. But we're going to go into that design criteria file. And notice with the alignment selected, I have a link to get to the editor. So this is a much better way to customize your standard or your design criteria file. So what we recommend here is if you want to start with one of the AASHTO standards we deliver and then make your modifications, is just to open that file here, and as soon as you open it, to go directly to Save As and save it as another name. And then you can make your edits and not impact the original file. And that's what I've done here. And again, I haven't changed anything yet. I've just got it ready, got a new name. So let's take a look. So we have some unit settings. And first thing I want to look at under alignments is the minimum radius tables. So we told the minimum radius lookup to use a Emax or a max super of 6%. So let's look through for design speed. So we also set a 50 miles per hour design speed. So at that, the lookup table says that the minimum radius should be 833 feet. As I mentioned, we have a 1200 foot radius, so we're well within that. Notice at 60 miles an hour, however, if I had set a 60 mile an hour design speed, we would be violating that. So let's set that and see how that performs here. So I'm going to go back to Alignment Properties, change my design speed to 60, hit OK. So you can see immediately I have a warning in the file. And if I hover over that warning, it will tell me what the minimum radius should be from the table that we just looked at. So that's very simple. I just wanted you to see how that works if you're not familiar with it. Okay, so I'm going to go back to Alignment Properties and set that back to 50 so that we're in compliant. And you can see the warning goes away. I'm going to go back to the Design Criteria Editor, and we're going to move to the next piece of this file, which is the Superelevation tables. Now we'll mention under Attainment Methods, I'm skipping this because we're going to save this for a later date, but this controls how to place it once it comes up with a transition length from the table, how to place it along the alignment or the curve. Okay, but we're going to come back to that in a later video. So we're going to go down to Superelevation tables. I'm going to go to the Emax 6% because that's my setting. I just want you to see where these values come from. Design speed of 50. Alright, so I had a 1200 foot radius, so let's scroll down till we get in that area. Okay, so you can see at 1160 feet my superelevation rate should be 5.6. At 1280 feet, it should be 5.4. Okay, so let's go Calc Super and see how this behaves. I'm going to go to Superelevation Calc. Calculate now. We did all this in the part 1, no shoulders. See how this retained the data from my alignment settings and finish. So you can see from the table here, begin full super, my full superelevation rate, or the maximum superelevation rate I achieved, was 5.6%. So that matches up exactly with the 1160 foot radius line in the table. So why did it pick that and not, why didn't it go up to 1280, or why didn't it interpolate between? Well, we'll come back to that. So just remember, we selected the lower 5.6, which lined up with the 1160 foot option. So I'm going to go back to the Design Criteria table, our editor, and we're going to go back into the 6% area. So we kind of see how now the design speed versus radius and super rate work. Now I'm going to go down to the transition length. This is how it decides what is my transition length and where that comes from. So if I go down to 50 miles an hour transition length, and again I'm looking for 1200 foot radius. Before you saw that it went with the lower radius of 1160, and that determined a 5.6% maximum super elevation rate, or where it went in full super. So if that's true, it should also select 1160 foot in the transition length for the super elevation. So we basically picked the rate. Now we got to pick the transition length. So 134. So let's see if it did that. If I go back to super elevation, view tabular editor, you can see directly here the runoff is 134 feet. So it selected the same row, the 1160 foot row, as we did when the table was selecting the maximum super elevation rate of 5.6. And notice, and this is just a side note, notice how the default attainment, you remember those formulas I said we'll come back to? Notice it took the length of that table as the runoff length, not the total transition length. Okay, and then those formulas decided how much or what was the run out based on that runoff. And so now you can see the total transition length of 181.86. Okay, so the 134 went directly into the runoff, and that's because of those attainment formulas that I briefly showed you. So this is well and good, but what if I didn't want that? A lot of people would rather interpolate that table in the design criteria file. So what I'm going to do here, and this is just a tip here, I'm going to clear super data. The change I'm about to make in the settings of Civil 3D, it really works better if you go ahead and clear all the super before you recalc it. Okay? So I'm going to clear the super elevation, so now I have no super elevation calculated, and I'm going to go to the settings button on the tool space. In alignment, I'm going to right click on edit feature settings for alignment. Notice here we have a super elevation option. I'm going to scroll down to the bottom, and there is an option called radius lookup method. Notice the current setting is use nearest lower radius. And that's exactly what we saw happen with the table when we selected our maximum super elevation rate and when we selected our transition length, which in this case, because of our formulas, is the runoff length. Let's set this to interpolate radius and then hit OK. So when I make a change like that, I really need to flush the super before I recalculate so it will sync up properly. I'm going to go ahead and save the file since I made a change like that. And now I'm going to go back, select the alignment. I'm going to go to calculate super. Yes. Next. Next. Just checking so I can turn my shoulder off. And now notice the difference. For my full super elevation rate, I interpolated between the 5.4 and the 5.6 because 1200 fell between those two radius options into 5.53%. And what about my length? Same thing. It selected a length that was an interpolation between the two runoff lengths before it placed it into this field. So I hope this has given a little more insight to how the design criteria works when it's selecting maximum super elevation rate and transition lengths. In a future video, we'll take a look at making some edits to those transition formulas, which will give us more control over how the transition lengths are applied. I hope this has been beneficial. Have a great day.